Here we are going to solve a series of linear inequalities, express the solutions using interval notation and a graphical representation. The first inequality is 0 is less than 7 minus 2x. This is equivalent to 7 minus 2x is greater than 0. I can subtract 7 from both sides of the equation to get negative 2x is greater than negative 7. And then when I divide by a negative or multiply, I need to change the direction of the inequality to get an equivalent result. So I'm going to divide both sides by negative 2. That's going to give me x is less than 7 halves as the solution. In terms of interval notation, that would be negative infinity to 7 halves. And in terms of the number line, we'd have an open circle at 7 halves and all of the real numbers to the left. Now, it's interesting to think about this in terms of functions if you have studied functions. And so here we have the function y equals, I'm going to call it negative 2x plus 7. And it says that that has to be greater than 0. Well, we know that the graph of y equals negative 2x plus 7 is crosses the y-axis at 0, 7 and has slope negative 2. So its graph would be something like this. And so this is y equals negative 2x plus 7, and this is y equals 0. So we're looking for the values of x where the y equals negative 2x plus 7 is above 0. And so that would be all the points to the left of where the two functions intersect. And when we check out this intersection point, it is indeed 7 halves 0. So on the number line, we would have all values from 7 halves to the left. Let's look at the second example. The second example is 2 minus 3x is less than or equal to negative 10. And so I can subtract 2 from both sides to get negative 3x is less than or equal to negative 12. Dividing by negative 3 will change the direction of the inequality and give us x is greater than or equal to positive 4. This is the interval for x from 4 to infinity, where 4 is included. On the number line, we'd have a closed circle at 4 and all real numbers to the right. Using the same idea that I did in the first example, I'd like to graph y equals 2 minus 3x and y equals negative 10 and see, and see where the value 2 minus 3x is less than or equal to negative 10. And so this time, 2 minus 3x crosses the x-axis at 0, 2, has negative slope of -3. And y equals -10 would be below the x-axis and so we're asking, where is 2 minus 3x, the y value on that graph, smaller than -10? Well, that is actually happening starting at the intersection point here. And going to the left. And I'll let you confirm that the intersection point is for -10. And so in terms of the number line, it's all numbers greater than or equal to 4. So let's look at the third example. In the third example, we have 1 minus x is greater than or equal to 6x plus 8. So first of all, we can subtract 1 from both sides. And subtract 6x from both sides. This gives us -7x is greater than or equal to 7. So dividing both sides by -7 gives x less than or equal to -1. In interval notation, this would be from -infinity to -1, including the -1. On the number line, it would start at -1, including the -1, and go to the left. This time, I'll graph two different functions, one with y value 1 minus x and one with y value 6x plus 8 to confirm, using our graphs of functions, the result. And so one minus x has y-intercept 1 and slope -1. So the y values here are all 1 minus the x values. On the other hand, 6x plus 8, y equals that, crosses the x-axis at 0, 8, and has a very positive slope of 6. And so this is y equals 6x plus 8. So where are the y values of 1 minus x greater than the 6x plus 8? It appears as if it starts at the intersection, and I would say this time goes to the left. So for all of these x values, the y computed from 1 minus x is larger than the y computed from 6x plus 8. And again, you can confirm that the intersection point here is -1, 2. And so it's all values from -1 to the left, including the -1. The last example, involves some fractions, so it would be nice to be able to avoid some of those fractions. But let's first of all get rid of them by multiplying everything by 6. So if we multiply all 4 terms by 6, we'll have 6 times 5/3 minus 6 times 1/2 x is greater than or equal to 6 times 7/6 plus 6x. And so we'll have 10 minus 3x is greater than or equal to 7 plus 6x. And now I can subtract 10 from both sides to get negative 3x is greater than or equal to negative 3 plus 6x. Subtract 6x from both sides to get negative 9x is greater than or equal to negative 3. And divide both sides by negative 9 to get x is less than or equal to 1/3. And so in interval notation, negative infinity to 1/3, including the 1/3 on the number line, everything starting at 1/3, including 1/3, and going to the left. But now let's take a look at these two original functions to confirm the result. And so the first one has slope of negative 1/2 and y-intercept 5/3. That's bigger than the 7/6 because it's equivalent to 10/3. And it has slope negative 1/2. So this is y equals 5/3 minus 1/2 x. Whereas the 7/6 plus x crosses the y-axis a little bit below the 5/3 and has slope 1. And so this is y equals 7/6 plus x. And you'll see that the first function is on top to the left of the intersection point. And so for all of these values of x, and I'll let you confirm that this value, the point of intersection, has x value of 1/3, and we can compute the y value by going 7/6 plus 1/3, which is 2/6. So this will equal 9/6 or 3/2. We don't really need the 3/2 in this problem. All we need to know is which function is on top to the left of x equals 1/3. And that finishes this video.